right, our essential question for today is, why do we use the scientific method? This section of notes actually has two targets, 2 and 3. Target 2, I can explain, identify, and apply the parts of the scientific method. Those include the hypothesis, variables, graph, and conclusion. And target 3, I can tell whether an experiment is valid, meaning it's a good experiment using the scientific method. Okay, so if you notice, these notes look a little different. I did not give you the questions this time. So again, you set it up just like you've been taught. Essential question at the top, draw your line, leave room for questions on the left-hand side, notes on the right-hand side of the line. So for example, number 1, I've got the notes with the main idea. You would put in number 1 over here and put your question that goes with this notes. So, number 1. Why is the scientific method important? There's your question. I would put that over there on your left-hand side as number 1. Okay, the scientific method, I always abbreviate SM, is a consistent process used by all scientists to compare and contrast results. So this is a process that all scientists follow. And because all scientists follow this process, we're able to, again, compare and contrast different results across the world. So it's just a consistent process that all scientists use. So now I'll start talking about what are those processes. So the first step of the scientific method is called the purpose. The purpose is the question you are experimenting about. This is what you want to know. For example, here's the question we're going to be using today. At which temperature will algae grow the best? So that's our purpose. That's our question. Right? And it's always written in the form of the question. So the first step is your purpose. What are you trying to solve? The second step is your hypothesis. So this is an educated guess that answers your question, and it's based on your experiences, your observations. It's always written as a I think because. So for example, I think algae will grow the best in warm temperatures because warmer temperature will increase reproduction rate. So I gave what I thought in answer to that question and why. I think algae will reproduce faster in warmer temperatures. Okay? So that's how you will always write a hypothesis. I think, and then you give me your reasoning why you think that. Your because piece is based on your experiences and observations. The third step is the actual experiment. So these are your procedures used to test the hypothesis. The procedures are written in a list format. They're usually a numbered list that you follow to complete the experiment. Before you can do the procedures, though, you have to identify variables. So if we take a look at the independent variable. The independent variable, I always put this symbol, this triangle, next to the independent variable. The reason why is the triangle is the delta symbol or Greek symbol that means change. And the independent variable is the one variable that you change in an experiment. And you only ever change one variable. If you change more than one variable, then the experiment is not valid. So that's part of target 3, being able to identify a good experiment. A good experiment only has one variable that changes in a lab. So with our question, at which temperatures do algae grow the best? Temperature is what we're going to change. So we're going to put algae in different temperatures and see which temperature the algae will grow the best at. Then we've got to look at a dependent variable. The dependent variable depends on the independent. It is the variable that you are measuring based off the independent variable. I always put a little tape measure next to the dependent variable to help remind me that this is what I'm going to measure. So if we're going to change the temperature with the algae, we're going to measure how well they grow, how many they grow at different temperatures. So the algae growth is your dependent variable. Then another variable are your constants. These are variables that stay the same so that you only change the independent variable. So I only want to measure how temperature affects algae growth. That means I have to keep everything else the same. So I have to keep the environment the same. So if I'm only changing the temperature, then I have to keep the same amount of water that the algae are in. the same amount of food that the algae get, and I have to keep the same shape of the environment. Okay, so I would probably grow these algae in containers. I'd want to keep the containers the same, the amount of water, the amount of food the same, so that the only thing I change would be the temperature of the water. So constants are variables that you keep the same so that you only change the independent. Then your control is the standard for comparison. It's one of the independent variables. So if I was going to change temperature, I would grow algae at cold temperatures, room temperature, and warm temperature. The standard rate that most algae grow in, I would say, would be the room temperature. So that is your control. So then you're going to compare, okay, how many algae grow at room temperature? Then you're going to compare, do they grow better in cold temperatures or warm temperatures? You compare those to how many grow at room temperature. So that's what the control is, the standard for comparison. And you're going to get a lot of practice with identifying variables. Okay, the fourth step is your analysis. So this is where you're collecting and recording your data. Your data is usually always displayed in graphs. It's collected in a data table and then displayed in graphs. You either use a bar graph, which we use to compare our data. Line graph is change over time, and I'm going to give you examples of those in a minute. So let's take a look at our data table. Really easy way to remember how to set up data table and graphs. You're only using the independent and dependent variables. So your independent variable in a data table, I'll put that in bold so you can see it better, always goes in this first column. So our independent variable, we would actually put where that IV is, we would put temperature, okay? Because that's what we're changing. You wouldn't put IV. So I could even take that out and I could actually put in temperature. That is what we would want to be changing. So I would put, whoops, misspelled that, temperature. And you would want to write it all the way out even though I abbreviated. Okay, and I make that a little bit smaller so it fits into the box. Okay, so the independent variable is what goes in this first column. And one thing I forgot to do, you always want to put the units. So we're measuring temperature in Celsius because that's the metric unit for temperature, not Fahrenheit. So this is where the independent variable goes. Okay, and you notice we have three independent variables. We have cold temperature, room temperature, warm temperature. So I want to identify those and put them in. Your dependent variable is the variable that you measure. So the variable that we're measuring is algae growth. So I would want to put that in there. Whoops. Nope, I messed up a little bit. So I would want to put algae growth here. That is my dependent variable. So the dependent variable goes in the next column. Now if you notice, the dependent variable has been broken up into three different columns. That's because whenever we do an experiment, we don't just measure something once. We test it more than once to get more accurate and more valid data. This goes with target 3. Not only an experiment has to be valid if you only change one variable, the temperature. In order for it to also be valid, you have to test the dependent variable more than once. So that means you need more than one trial. We call these trials. You need at least 3 trials for an experiment to be valid. Okay, so what we would do is we would set up algae growth at cold temperatures, and we'd have 3 different ones that are being grown in cold temperatures. 3 different ones grown at room, 3 different ones grown at warm temperature. And then we would measure the algae growth for each of those. So let me put some data in to show you. Okay, so if we put some data into the data table, you can see that we have 3 trials of each of the different independent variables, and then to get the average, you add them up. So I'd added 5 plus 6 plus 5, and then you divide by 3 because that's how many numbers there are, and that's an average of 5.2. Okay, so once we've got our data table and we've got all our data entered in, now we've got to do the graph. So when you do a graph, it's very easy to remember how to set it up. On the y-axis, which is the horizontal line, you always put your independent variable. So just go back to your data table. Your independent variable is temperature. So you label it temperature, degrees C, so we know what unit it's measured in. And then you put in your independent variable. We've got cold temperature, room temperature, warm temperature. Okay, that's how you label the x-axis. Then on the y-axis, which is the vertical line, this is where your dependent variable goes. So this would be your algae growth. So you would record algae growth right here, and then you would have to come up with a scale. So we're going from 5 to 7, so we could probably count by ones. This point right here is always 0, 0. So you would start this one out as 0, and then you would do, each line would be a 1. 1, 2, 3, 4, until you get up to 11. Okay? Now, if your data is a little bit wider, farther apart, then you might have to count by 2s or count by 5s or even count by 10s. But you'll get the hang of that the more graphs you do. And then what you do is you have to decide, am I going to do a bar graph or a line graph? So a bar graph compares data. So you have to ask yourself, am I comparing cold temperature to room and water and vice versa? If you are, then you're going to do a bar graph, which we are. We're comparing the cold temperature to room temperature to warm temperature and algae growth. So we are going to do a bar graph. Now, line graphs mean change over time. So that means something is changing over time. So if you look at your independent variable and you have some unit of time down here, maybe this was days, weeks, years, seconds, minutes, that usually tells you you're always going to do a line graph. When we get into our biology unit this year, you will probably do a lot of line graphs because you'll see a lot of change over time. So then you would just plot your data, okay, and as you can see, the warm temperature had the most algae growth, okay. So then the fifth step, which is the last step of the scientific method, is your conclusion. Your conclusion is a logical answer to the question, the purpose, based on your data. There are 5 things you will always do in this order in your conclusion. The first thing you're going to do is restate your hypothesis. Okay, so that's the first thing you always do. So that's pretty easy. You just go back and you restate your hypothesis. So we would write in the conclusion, okay, I think algae will grow the best in warm temperatures because warmer temperature will increase reproduction rate. So you would write that down as the first part of your conclusion. Then you're going to look at your hypothesis and you're going to ask yourself, does my data support my hypothesis or does my data not support my hypothesis? And you write it just like that. Data either supports or does not support the hypothesis. So we said in our hypothesis that warm temperature would have more algae growth. So you come back to your analysis, your graph. Does the warm temperature have the most algae growth? Yes, it does. So then you would say, my data supports my data supports my hypothesis because the warmer the water or the warmer the temperature, the more algae grow. Okay? So that's real important. You've got to look at your data and see whether your hypothesis is supported or not supported by your data. And it's okay. Sometimes you'll get, my data does not support my hypothesis because room temperature has the highest growth of algae instead of warmer temperatures. So you might get one that does not support it. That's okay. Then the third thing you do in your conclusion, what I learned. Okay, so what did you learn about this experiment? And it's usually based on your target. Okay, what I don't want to see is you could put down, I learned algae grow the best in warmer water. I also learned how to follow the scientific method. Those are things that you put down. What did you learn about this experiment that relates to your target? Then, this is the one everybody always struggles with. Your labs always go with a target. So what you're going to be telling me in this lab is, why is this target important? So this lab that you're going to do is going to be on the scientific method because that's what our target is, 2 and 3. So you've already gotten your notes. Why is the scientific method important? Because it's a consistent process used by all scientists to compare and contrast results. So why is it important to follow the scientific method? It's important because all scientists follow the scientific method and you need to collaborate. And then the last thing in the conclusion, you always come up with a new question. So what's something else you want to know? It could be about algae, it could be about the scientific method, but it's a new question that you have based on what we've been doing. So that's the last step of the scientific method. And then, of course, I will give you class time. You will be writing a summary. Remember, minimum of 2 sentences that answer this question. Why do we use the scientific method? So you would need to answer that in 2 questions to be proficient. Okay, that's the end of our notes on the scientific method. Remember, these are all the steps of the scientific method. That's target 1. You will get a lot of practice with writing a purpose, writing a hypothesis, identifying variables, filling in a data table and doing a graph, and writing a conclusion. And then target 3 is on, is an experiment valid or not? It's valid if you've only changed one independent variable. Okay? It's valid if you have more than one trial for your dependent variable, okay, because you have to get accurate data, so then you take an average. So those are the 2 things you want to look at when you're looking at an experiment. Does it only change one independent variable? One variable changes? And did the data have more than one trial? So that we can make sure that we reduce errors, and because you will have some errors. So the more trials you do, the less that minimizes the errors, and that's why we take an average and graph the average. I don't know if I mentioned that. I think I forgot to mention that, but on the graph, you only graph the averages. That's what gets graphed. You do not graph the trials. So averages are what get graphed. Okay, well that concludes our notes for the day.